Yeah, I want to talk to you about genetic modification and gene technologies and their potential role in helping us create, I'm going to focus on plants, better plants for agriculture. So I was born in 1968, and that year there was a book out, The Population Boom, and people were really worried about the idea that the population was really starting to increase significantly. So 1968 is kind of about here, and the population has exponentially increased as predicted. I think we're about up to 8 billion people. So the book was saying that we wouldn't be able to produce enough food to feed all of those people, and there'll be mass starvation. But that didn't happen, and it didn't happen because really the Green Revolution, our efficiency in agriculture has kept up with the growing population. So innovations in agriculture, new varieties of wheat and rice that were dwarfed so you could add more chemical fertilizer to increase yield, various agrochemicals, control pests and irrigation and mechanization was really the savior and the reason why we were able to sustain the population we have without lots of deaths. But sorry. And I'll be right. Okay. But all those sort of things that led to increase in food production are the things that we see as the problems of today. The high levels of agricultural use of inputs and chemicals and fertilizers. And so what I really want to talk about is the potential, I guess, of gene technologies to help address these problems and make agriculture a bit more sustainable, and the potential role it can play in that. So genetic modification is a really old technology now, just like me. So 40 years ago, it was the first genetically modified plant, so 1983. Was the first one was produced, and so I was just comparing it to what cell phones looked like back in 1983. We've come a long way with cell phones. Now, no. So how far have we come with genetic technologies? Well, there's a few great examples of how genetic technologies have been really useful. The vitamin A golden one is kind of the poster child of genetic technologies. The idea that there's a compound, beta-carotene, that's made in plants but just doesn't happen to be made in cereals and rice grains, and just making that same compound that's made elsewhere in the plant in the rice grain gives you golden rice. Corn's already got beta-carotene in it, but rice and is yellow, but rice hasn't. So genetic engineering can do that. Iron deficiency is a big problem worldwide, as vitamin A deficiency is, and 2 billion people suffering. And so having plants that have higher iron, it would be a really brilliant thing to improve nutrition. And there's great work going on to use genetic technologies to increase the iron. This is a recent paper where we're getting sort of 3 or 4 times more iron in wheat, and that's just not out commercially yet. Golden rice is available commercially, and we are approved to eat that in New Zealand. It's deemed safe. In agriculture, plants aren't the best food source for animals in terms of nutrition. It takes a lot to digest grass, break it down, and so people are thinking about ways to make grass that is more nutritious, more easily broken down, and should lead to reduced methane production, etc. And so there's an alfalfa lucerne that's been out on the market in America that has reduced lignin, so it's easier to break down, and sort of a 20% gain in yield from that. AgResearch is doing a lot of great research. People will probably have heard about their HME ryegrass. The idea there is to engineer the plant so it's producing more lipids in the leaves, more nutritious, and again, it has good environmental benefits. High condensed tannins, and clover is another thing that AgResearch is working on to improve the digestibility, reduce bloat, and lead to reduced methane emissions as well. The research going on shows that we can create plants that are much better at taking up nitrogen, much more efficiently from the soil, so we don't need to add as much fertilizer on. So here's the laser pointer works. Here's an example here where it's an engineered wheat and rice, same result. So you can get the same yield if you put, say, 120 kilograms of rice of nitrogen on per hectare, then you get this yield here, but the genetically modified version can give the same yield with half as much nitrogen per hectare, and that replicates up to higher nitrogen. So you might be able to halve the amount of nitrogens used using this. Drought tolerance has been engineered in maize that's grown in America and is particularly useful in drought-prone areas. And finally, disease resistance is a really good example of how genetic modified can be used. The Hawaiian papaya industry was really almost devastated because of this virus, ring spot virus, and 1980s they developed a variety. It was a bit like, you know, us getting immunized for COVID. They just put a bit of the virus sequence into the papaya and it's resistant to the virus. Now in Hawaii, 90%, or might be more, 90% of the papaya that you eat is genetically modified. That just came out of the lab that was working in the university in Hawaii. Corn and lots of other crops use hybrid breeding, where you get two inbred lines and then you cross those together and you get hybrid vigor, but it's also a lot easier to grow. And what happened in maize production, when they started using the hybrid technology, then the breeding process was a lot easier. They used to get corn yields, 2,000 kilograms per hectare, and now they're way up to 9,000 kilograms per hectare. So the potential to improve crops and increase yield is actually tremendous. I mean, it's hard to underestimate how much gain plant breeders have been using by using that technology. In ryegrass, we can't use F1 hybrids because we can't inbreed. And in my lab, Rowan Herridge came up with this idea of how we could make inbred ryegrass using a genetic modification. The good thing is you only need it in the early stages. The seeds that would go to the farm are a couple of generations away from having that, because you only need that construct to make inbreeding. And I reckon ryegrass is probably kind of down here in the 1930s in terms of its genetic potential compared with what it could be if we have hybrid breeding and other ways to improve it. Ryegrass is really hard to breed and really hard to make an improvement. So huge potential out there. And there's lots of genetically modified crops growing on in the world, about 12%, 200 million hectares. So it's being used extensively worldwide. But because of the regulatory environment, the only people who have really been taking advantage of it mostly are big multinational corporations, and they got in early, and they've got canola, maize, soybean, cotton, the genetic modified, and that's really where the 200 million hectares are, and these four main crops. And there's been a lack of innovation, and those great examples that I've talked about earlier haven't really, are still a long way from coming onto the market, I guess, because of the regulatory environment. So we're back, what's that, a cell phone of the 80s kind of technology today. So what is in those crops is largely putting a protein that we know from 1930s that could act as an insecticide, and you can go and buy that from from nickels now, putting that gene, making the protein being made in corn or cotton, and it's an insecticide, and it kills the insects, but doesn't harm us. It's just a normal protein for us. So it's been highly effective, this crop, this idea that was commercialized in the 1990s. And herbicide tolerance is the other one that's the big trait. So it's really those two traits that are out there largely. So at that time, when those new genetic modification plants were coming onto the market, we didn't really know, and I couldn't as a scientist say what the long-term consequence of having genetic modification would be, the safety issues we couldn't answer because they hadn't been going long enough. So there was questions we couldn't answer, and understandably, I think the public was somewhat wary of this new technology. And so what New Zealand did is had the Royal Society, the Royal Commission on Genetic Technology, have a look at the topic and see what we should do. And their conclusions, going back to read the executive summary, is kind of interesting. They say about how genetic modification has been used as a research tool for sort of 10 years, a long time, holds exciting promise for enhancing international competitiveness of primary industry, so crucial to our country's well-being. It would be unwise to turn our back on the potential advantages, but we should proceed carefully minimising and managing risk. Technology is integral to the advancement of the world. As in the past, we should go forward, but with care. So that the Royal Society, the Royal Commission had really sound conclusions. And in that time, we're eating genetically modified crops. I'm wearing genetically modified cotton, so you all at the moment from plants. It's out there in agriculture and has been for a long time. And because of that, and that 28 years of research and checking on genetic modification and the consequence, as a scientist now, I can say completely it is a safe technology. We could create a genetically modified plant that isn't safe, but the technology itself is safe, and the crops that have been produced have been safe to eat. You might disagree with and not want genetic modification because of your worldview and other reasons, so that's fine. But as a scientist, we can say it is a safe technology. As a researcher, I want to use genetic modification and as a tool and try and innovate and create new cool things. This is from a colleague's email after an MB round where he didn't get funded. Somebody started to read it. So did you get any MB from MB? This was a colleague in Scion. The Scion-based assessors thought genetic technology was too risky for New Zealand. They liked the science, but didn't think gene editing, in this case, which I'll come to, could be commercially viable in New Zealand. So none of the Scion bids were funded, and the bid from a colleague at Otago was the same. Yep, as attached, some similar comments about GMs. I'm not sure this genetic technology is going to really catch on. Richard's sick of hearing such feedback, which I am, because it's not really understanding the process of innovation and that we need to be trying things, innovating to move forward. So genetic modified, and this was the comment that one of the reviewers wrote, it's genetic modified technology and unlikely to yield any economic, environmental, or social benefit to New Zealand. So it wasn't funded. So that was the view. So then when I was writing the talk, I went back to think about how long it took for cell phones to make an impact. And we could have had cell phones back in the 1920s or 30s, but innovation takes a while for people to get their idea around that it could be a useful technology, how it develops. The first cell phones released into cars, 1946, and then this guy made the first call on his great looking phone back in 1973. So if someone was reading the grant of that guy back in 73 and they suggested that thing would become useful and be commercially, take off, then that wouldn't be funded either. I can't get my cell phone out, but we all know what a modern cell phone looks like. It's not recognizable from the cell phones back there. And that's what innovation is really about. And innovation needs us to come up with ideas at the universities and things, and we need to test them. We need to plant them out in field trials. This is a field try of the HME ryegrass, and it's in America. And when I show my students this, they're like, oh, is that what a field trial is? It's just a few plants growing outside. And that's all it is. But we can't do that in New Zealand because it's too complicated to go through the regulatory hurdles. Cool. So, but it can be in Australia, and there's plenty of field trials going on in Australia around the place, including the condensed tannin one that AgResearch is doing. So unfortunately, AgResearch is choosing to go over to Australia and America rather than just putting it on a farm locally. And that's a really a loss of opportunities. But things are changing, so I should be positive. Technologies change as innovation happens, and the newest innovation is genome editing, that you might have heard of. And so it allows us to make very precise changes. We've been able to change the DNA through mutational breeding for years, since 1930s, just make random changes in the DNA and select out of that, and that's been a useful tool. Plant and Food have got a crop that's being sold through Wrightsons, where they use that technology. Plants in tissue culture were subjected to a chemical that just changed their DNA and led to herbicide resistance. So you can buy this clean crop brassica crop that has a genetic change, which is not regarded as genetic modification. And because of this, there's no scientific difference between modifications that could have been made with chemicals and the ones we can make precisely. People are recognizing around the world that actually we shouldn't be regulating based on how something was made, but the consequences of it. And so around Australia, gene editing is becoming, the rules around it are being loosened in India and EU and England. We're all thinking that we need to regulate gene editing in a different way. And that's why the National Party also has coming up with this idea that we need to look at our GE rules and make them fit for purpose. It's not because they're nice guys, really. It's really because we need, as New Zealand, to keep the same rules as our competitors internationally. That it doesn't really work if we treated a plant as genetic modified through gene editing, but the Australians don't. We have joint food safety with Australia, and if we had the same rules, if we're defining plants differently, it becomes really complicated, and just as an export nation, it becomes really problematic. So we need to be in line with our competitors. We need to all understand what a genetic modified plant is versus a gene edited plant, and that's needed for the regulatory environment. Cool. The Royal Commission also said, nicely, that a recommendation is to aim to encourage the coexistence of all forms of agriculture. Different production systems shouldn't be seen in opposition, but rather contributing. And Maori views should also be taken into account. So the question really is, can the different worldviews on genetic modification coexist and be respected, and so we can move forward, and those who want to use the technology can for the benefit of New Zealand. Cool. Thank you.